Hello and welcome to the section 3.2 lecture today for Algebra 1 Part 2. We're going to continue our look into some geometry stuff. Still talking about perimeter and area, keeping with that theme for this week. So let's just jump right in and get started. First thing we're going to do is look for perimeter. Just want to find the perimeter of these starting triangles. So taking a look here, we want to remember that perimeter is the distance around. Okay, in each one of these, I've thrown in kind of a distractor, kind of a piece that we're probably not going to need. And I put that in there for a reason, just to make sure that we know what we're looking for. So for the first one, we're looking for perimeter. And again, that's just going to be start at one point, track the distance that you've covered, going all the way around the figure and getting back to your starting point. Okay, so I'm thinking about 4 feet plus 8 feet, which is 12, plus another 12 feet, which is 24 feet. The next one, I have 3 centimeters, 3 centimeters, and 6 centimeters. So 3 and 3 is 6, plus 6 is 12. The last one here, 1.5 plus 3.3 is 4.8, plus 2.2, which is going to be, what did I say, 4.8. The 2 makes it 5, and then the 2 more makes it 7, so 7 yards. Okay, so not too bad on a basic problem for finding perimeter. Let's go ahead and look at something for right triangles specifically. And this would be the Pythagorean Theorem. So looking at a right triangle, in any right triangle, when I have these 2 perpendicular sides, they meet at a right angle. That's why this is here. Okay, they meet at a right angle. The 2 perpendicular sides are called legs, and I have them labeled as leg A and leg B. And then the third side, the longest side, is called the hypotenuse. And in that right triangle, leg A squared plus leg B squared is equal to the hypotenuse squared. And that's always true. And that's useful when you want to find the perimeter of a right triangle. You could also find it in other triangles where you were looking for, where they maybe gave you a couple perpendiculars and you could find the missing side using the Pythagorean theorem. Let's go ahead and look at this. To start here, we're just going to find the missing side, so we're going to use Pythagorean theorem. And then down below, we'll actually use Pythagorean theorem and find the perimeter. Okay. Now, because of all the squareds that happen, you're going to end up with some kind of ugly answers. Feel free to round to the nearest tenth, which is just 1 decimal point, to make life a little bit easier. So in this first one, I have the 2 legs. I'm looking for the hypotenuse. So writing this using this formula, we have 7.1 squared plus 7.6 squared is going to equal x squared. So I have some calculations to do. I'll grab a calculator. I don't have a good quick way to square, so a lot of times I just do it, and I'm actually going to write it out. So we have 50.41 7.6 times 7.6 57.76. And that's still equal to x squared. And 50.41, oops, that's 60, plus 57.76. And then I want to take the square root. Now that's this button right here for me. And that's how I end up solving this, because I have 108.71 is equal to x squared. Now to undo the x squared, we want to take the square root of both sides, because the square root of x squared is just x. And when I take the square root of this, it's going to be something around 10. We have 10.4. And that's our missing side. In our next equation, we have the hypotenuse. We're looking for one of the legs. So that gets a little bit different. In order to do that, I'm going to say that x squared plus 9 squared is equal to 13.2 squared. So leg squared plus leg squared equals hypotenuse squared. So let's get our x squared down. 9 times 9 is 81. I can do that one pretty easily. And then I want 13.2 times 13.2, 174.24. I want to take that number and subtract 81 to solve this equation, and I get x squared equals 93.24. And then to solve this, I'll take the square root. Since I already have it in the calculator, I can just hit square root. And we get, let's call that 9.7. It says 9.65. So I'm good with 9.7. Okay. And on this last one, kind of similar, I'm looking for one of the legs. So we'll say x squared plus 7.2 squared equals 10.8 squared. Get this a little bit quicker. 10.8 squared minus 7.2 squared yeah, that gets weird. Okay. Let me try that again. 10.8 times 10.8 minus 7.2 squared. Okay, 64.8. And that's x squared. Then when I take the square root, I'm going to get something pretty close to 8. Yeah, call it 8.0. I think that's, maybe we put two decimal places in there. It's not 8 because 8 times 8 would be 64, but it's pretty close. Okay? All right. Let's use those skills now to put it all together and find the perimeter of these triangles. Okay, it looks like in all three of them I'm looking for a leg. Okay, I'm given the hypotenuse on all three of them. And it might be worthwhile to go through and just make some kind of a mark on your hypotenuse on each one so that you know you can put it into the Pythagorean theorem correctly. Okay, because that's the one side that really matters. So on this one, we'll just call that x like we've seen already. So x squared, just the one, no, not quite. Okay, I was going to say, is that just the same one that we just had? Not quite. So plus 7.1 squared is going to be equal to 11.1 squared. 11.1 times 11.1 is 123.21. That's kind of a palindrome. I need my 7.1 squared. I guess I already knew that. I did it in the problem up above. 50.41. 123.21. Kind of works its way up, then back down. So 123.21 minus 50.41, 72.8. And then to find x, I want to take the square root of that. Call it 8.5. Then for the perimeter, we want to add up all the sides. And just to make it go a little quicker and a little bit less thinking. Oops. Yeah, I'm multiplying. I don't want to multiply. Let's go 7.1 plus 8.5 plus 11.1. 26.7. And there we go. On the next one, I'm looking for x squared plus 5.4 squared is equal to 12.6 squared. Maybe we try to do this part a little bit quicker. 12.6 squared minus 5.4 squared equals, and take its square root. I call it 11.4. So then the perimeter is equal to, let's give it 11.4 plus 12.6 plus 5.4. And we get 29.4. And I should put units on those. This was kilometers, this is centimeters, just to get into that habit. This last one, we have x squared plus 8.6 squared equals 9.4 squared. We're going to take 9.4 squared minus 8.6 squared, and then take the square root. Let's call it 3.8. And so, nope, I don't need x. I already found that. So my perimeter is going to come from adding all those together. Say 3.8 plus 8.6 plus 9.4. 21.8 kilometers. And there we go. Let's see what the back has for us. So on the back, we're looking for area. And first thing I want to do is take a look at this little exploration, because it's nice to know where some formulas come from. So first thing I want to know is this shape on the right. It's a parallelogram, and it has labeled for us a base and a height. We talked about this last time, but what is the area of that shape? Okay. The area of that shape is going to be equal to the base times the height. And now it says, and I'm going to use a straight line because I can cheat and make things look good like that. It says if I draw a line from the bottom left corner to the upper right corner, that will split my shape into two what? What is this shape? This one right here. This shape right here would be a triangle, and it's actually the same size as its counterpart. Same size as this one here. and the exact same size, which is important. It's very good to know that those are the exact same size. So not only does it split it into two triangles, but more importantly, two congruent triangles, which congruent in math means same size, same shape. So into two congruent triangles, okay, that have the same area. So since it splits it into two things that have the same area, then if we wanted to know the area of just part of that, if the area of the whole thing is base times height, the area of half of it has to be 1/2 base times height. The other half is down here. Okay, and that's what we get. So in the area of any triangle is, let's say that its area 1/2 base times height. And that's why, because any triangle can be made from a parallelogram, just like this one. Okay, we could have done the same thing if we drew a line from the top left to the bottom right. Okay, that would have, and gotten rid of this one, and that would have told us the area. Okay, so let's go ahead and use that. Now, the trick here is that the height is the distance from what we consider the base, that perpendicular to the base, and goes to the opposite vertex of the triangle. So a lot of times written in red on these problems is where we're going to find our height. But there's some other numbers out here that are kind of meant to distract us and kind of scary sometimes, because I would look at this and say, well, this line's on the bottom, so it's the base. But if that's the base, I'm missing the height. The height would go from the opposite vertex to perpendicular to that base. I don't have that length. Okay, and I definitely don't want to find it because that's not very fun. Okay, I'm going to use what they give me, and to find this area, I'm going to treat this as the base. And so the height goes perpendicular to this vertex. And sometimes that height can be outside of our triangle. That's okay. Okay, but that's why this is given here. I'm still only finding the area of this kind of skinny triangle, but I'm using dimensions that are outside of it. So the area of this triangle has to use 6 as the base and has to use 6.3 as the height. So it's going to be 1/2 6 times 6.3. And I guess a calculator would be helpful. We use 1/2 as 0.5, so that it's a little bit easier to put in. And we get 18.9. Oops. Since it is area, it is a squared measurement. Remember, we're finding the space, the number of little squares that fit in this shape. And they have to be full squares to count. So we do need that. We do need that to say squared. Next one. Always look at what height you're given, and whatever side that is perpendicular to tells you what your base is. So this is my base. This is my height. So I'm going to use those. Area equals 1/2. My base is 12. My height is 7.9. Using 11 in this problem would be incorrect because I don't have that. I don't have the height to that 11 kilometer side. So we'll go 0.5 times 12 times 7.9. And we get area is equal to, I didn't think about it, 47.4. And those would be square kilometers. Last one we have here. So we've got a height right here going to this base. There's 2 other distractors. We're not using those. If you want to cross them out, cross them out. then you won't get tempted to use them. So I have to use 3.3 for my base. So 1/2 times 3.3 times 3.7. Now, the question I always get is sometimes I will make the mistake of typing in 0.5 times 3.7, and I get people saying, wait, you did that in the wrong order. Well, it's multiplication, so the order doesn't really matter. So my area is equal to might as well put it all, 105. And that would be square feet. Okay. All right, so summarize your notes. Put any questions you have over on the left. I'm probably going to start using some of these problems for your homework problems. So I would make sure to start looking at this video if you want to get the answers to those problems. Anyways, I hope you have a good day, and we will see you in class.